So we're back out here on this slow progression of getting this unit up and running after being dormant for a year, since the business that was in this building moved out and a new one is moving in. And remember, this had the isopolar copper that had leaks in it. We got 2 lines we're shutting off to this whole system. Now this is a 16-ton unit. Let's see if I can zero in here. Where are you at? Focus. Right there. So this is a 16-ton unit. And this system itself, the refrigerant capacity was, where are you at? 23.6 pounds. So just the unit itself holds 23.6 pounds of R410. Now I have to re-engineer the system and rethink it because the customer doesn't want some heads in some areas. Some things are being cut out, are not necessary. But the system was maxed out with heads. It was designed with the piping of the heads. You have the adder of the refrigerant. I'm bringing this back in. Remember, it had leaks in the refrigerant piping, and so the system was at 0 psi when I got to it. So anytime you're at 0 psi, that means you not only did you have leakage out of the system, you have leakage into the system. So every time the piping in the unit got hot in the daytime and copper got hot and the air or the refrigerant in the piping got hot, it expands. And if you have a hole big enough to get 0 psi, that means you blow air, you blow mass, material out of that hole. But at night, every night, when it gets cold and all that copper and that mass of gas inside shrinks, it contracts and it becomes a negative. And that hole, well, it's like a hole in a ship. Water goes in. Well, guess what went in? Atmosphere goes in. You get moisture integration, so you get moisture contamination. I left this on the vacuum pump overnight. I've had it shut off for 5 minutes now. Here's my vacuum decay. Unsatisfactory, 670 microns. Remember, these systems don't have filters, dryers in them, so there's no dryer to change out. And all I could do is leave it on vacuum. It's a used system that has gas inside of it. You got a mile of copper pipe going throughout the building all over the place. You have a huge accumulator. You got like a 3.5 foot long accumulator in here. You have all the oil inside there. You have 2 large compressors inside there. You have all the oil and moisture refrigerant trapped underneath. So you have an old used system that was exposed to the atmosphere. So there's nothing you really can do. So this is gonna have to live good as it's gonna get at a vacuum decay of 673 microns. But while I'm still getting ready, I'll open it back up and let it go some more. It got down to 387 was its when I got here this morning. It was at 387. But remember, that's with the vacuum pump on, running with the micron gauge at this point, not at the point inside the system. Inside the system, if I really wanted to read it, I'd take a micron gauge. I would go all the way to one of the ball valves that are located out here somewhere in the middle of the building. That's where all the ball valves are located. So that gives me a point to put a micron gauge, far away location from the vacuum source, and I would take the vacuum source reading from down here, or the farthest unit, what would be all the way out at the front of the building and down on the first floor, not on the second floor. This is a 2-story building, and there's air handlers second story and first story. What else can I say here? Oh, so since some air handlers are going to be locked out of the system with ball valves, you do not fill the system back up with the adder and the amount of refrigerant that it originally came with. There's a quantity of refrigerant that is an adder for every size air handler. Every manufacturer, every model number air handler has a certain amount of adder. So like our 76,000 BTUs systems out there, let's just pull some false number out of her head as an example and say they want 3 pounds 2 ounces of refrigerant added for every air handler at that BTU output. and then say there was a 96,000 BTU and say they want 4 pounds for that one. Then we have the little small framed 36K air handler that's located somewhere over in that side of the building, and say that one they want 1 pound 12 ounces. These are all made up numbers just off the time, but I'm giving you examples of what an adder is for the air handlers. Now you have the piping. So this is not copper piping for refrigerant, but we're going to talk about piping. So now remember, automotive guys definitely don't know this, but you have your suction line, that's your large vapor line. Then you have your smaller line, that's your liquid line. For every foot of whatever the diameter of the line is, you have a certain quantity of refrigerant. So let's say this is 3/8 line. 1 foot of it, let's say for example, if I measure 12 inches and I fill that up with a column of liquid refrigerant at 70 degrees Fahrenheit. I'm sorry guys, I'm not using Celsius for you in the rest of the world. I'm in the dumbass USA who uses screwed up math. So yeah, 70 degrees Fahrenheit with 12 inches. Let's say I'm gonna pull a number out of my head of 0.06 ounces of refrigerant per foot. If you had 100 feet, just move the decimal over, and that's how much refrigerant you need. If you had a 1/4 inch line, so let's say this was a little tiny 1/4 inch line, and we're going to say 0.29 ounces of refrigerant per 12 inches. Every 12 inches is a foot. Multiply that by how many feet, and that's how you come up with your adder for all that line. Well, these different size heads that are in this building have different size liquid lines on them, and I had to actually get up in the air and manually measure every foot of line from their start for where the head is, make all the bends through the walls, curves. You got to remember, when you make curves, it's not a direct line. So to get up here 12 inches, if you come and you bend 12 inches, you have more area in a bend to get up it, especially when you do like S's. When you climb that 12 inches, there's a lot more than 12 inches there. So every time you transition to a different height or around a corner, you got to add. So I manually went around, measured the remaining refrigerant lines. I just shipped off all those numbers to my son. He's gonna do that. I'm the manual gopher boy out here working like an installer. My son is the brains. I'm giving the responsibility to him and gearing him up towards all the engineering and all the load calcs and everything. I'm giving him all the responsibilities of that, because when I'm not around, he has to take over, decide what he wants to do for his life, not have his parents hold his hand, and be that surprise day when dad's not around and he's like, what do I do now? So that has to be done. So I'm going to go down, get my scale, and get ready to add the 23.6 pounds into this. Hopefully my son calls me back with the adder, and then I'll add the adder back into the system. Remember, we have an electrical problem on the system. Down there at the LGMV Smart, no, LGMV, the AC Smart. On the AC Smart on the wall, which is the control panel, somebody cut the wires. And I think they cut the wires when the power was on, because now there's a black screen and it doesn't work anymore. And that's a $3,000 device. This is what happened when people work on stuff. They don't know what they're touching. They go, oh, this little thing, I could just move this off the wall. This wire, I'll just cut through that. Don't you make sure power is off first? So they might have just, with their little $3 Home Depot snips, that multiply zeros behind that $3, and that little $3 snip just became $3,000. All right, guys, catch you in a little bit when we get back onto this unit. This was installed several years ago, and they last forever, except for the isopolar line set that leaks like a sieve. Some of the shittiest copper ever to hit the world's market, and the company should be put out the business and forced to pay retribution back to all contractors that have to pull out all the isopolar and give the customers new Mueller copper, and basically shut that, impound their banks, seize all their assets, sell off all their assets, liquidate all their funds, and distribute all that money back to whoever purchased isopolar. You could tell I don't like isopolar copper. I feel sorry for all the customers and the guys who are replacing it, including my sad ass who has to pull this shit out all the time and replace it. All right, see ya.